Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Thank you, everyone. Welcome into the Computer America Show. Everyone, I hope that you are doing well and you are ready for today's program. Because today on the show, we have the one, the only, Ralph Bond, who'll be joining us here in just a moment. He is our science and tech trends correspondent. And if you haven't sat in for one of his shows, and for those who have, you know, it's going to be a very fun time because he picks a number of stories that you can, of course, follow along in the show notes. We'll mention that in just a minute. But yeah, it's a number of stories that will have you, looking forward to next week and the week after because they're always positive. They're always good. And a lot of crazy stuff happening out there in the world. This is our little oasis, our little getaway from that science and technology are improving people's lives. And it's all over the world. It's doing it every single day. So everyone, computeramerica.com. That's where you'll find everything, including past shows, future show notes, articles, reviews, and of course, podcast directories. Everything you need to know can be found in one place, computeramerica.com. By the time that you hear this, you will, of course, be able to, go check out that on the site. So with that being said, no real big announcements. Obviously, Thanksgiving. Hopefully, everyone out there is going to have a great Thanksgiving. I'm going to leave that up to Ralph. We'll talk to Ralph, and he'll let us know in just a minute if we're going to have a show or not. I'm totally up for it, but hey, it's the holidays. I don't mind giving him a day off or two here and there. So, and let's face it, this year's been a weird one for our schedule. So, everyone, welcome onto the program once again. Our science and tech trends correspondent, Mr. Ralph Bond. Ralph, how you doing?
I'm doing great, and yeah, we'll see about Friday after Thanksgiving, good old Black Friday, they call it in retail, of course, as everybody knows. So yeah, I think offhand we will. I'll check with my wife and make sure our schedule's okay with that.
You just let me know, and everyone, if we do end up having it, hey, computeramerica.com, that's where you'll find that, or of course, social media. So yeah. Ralph, thank you for at least being here today, and today you have brought us a number of stories. So as I said before, for people who have not been with us, Ralph, why don't you go ahead and give them a quick rundown?
Sure. Ben kind of gave a sketch of what we do, but every Friday, what we do is we look at 4 recent articles that show us key trends and developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow. Across the board, you name it, everything's eligible. And most important of all, as Ben mentioned before, we're going to give you a relaxing, uplifting, positive oasis from the world that we live in, where we're worried about World War III and all. No, none of that. It's all going to be positive, and you're going to see the hope that science and technology brings for a better future tomorrow.
Absolutely. And story number 1, I think, really shows that because it looks like we're going to find a way to build better, bigger ants. I assume no. 1,000 times their weight. I, of course, associate that with ants. But
Yes.
Story number 1 is going to be something that, is the applications are pretty immediate, but also, hey, very, very interesting and what could be possible in the future with this. Ralph, story number 1.
Yes, story number 1 is in the world of soft robotics, which is a very, very active field these days. This story comes from Interesting Engineering, a really good outlet. And the headline is, Soft as Skin, Strong as Steel, Powerful Magnetic Muscles Lift 1,000 times their weight. Wow. This is a really great story. So here we go. Soft, human-like artificial muscles are vital for robotics, wearable technology, and medical devices. Now, a team of researchers, and this goes to Ben's point earlier, we look at stories from around the world. This one's coming out of South Korea. So the Ulsan National Institute of Science and Technology in South Korea has developed an innovative magnetic composite artificial muscle. This new material can adapt its stiffness, transitioning from soft to rigid and vice versa. And it's been engineered to be as soft as skin, but remarkably strong. Moreover, this material's stiffness is a mind-boggling, get ready for this, 2,700 times that of traditional materials used to date for soft robotics. That stiffness factor.
Yeah,
amazing.
I need to kind of Google stiffness. So the extent to which an object resists deformation. So so it's not about bending or anything like that. Ralph, like sometimes when talking about materials, and this happens on the show when we talk to especially audio people or about audio. I don't know if you've ever talked to someone who's like really big into audio. They do this thing where it's like the warmness of the sound, the fuzziness, the ability to feel, like they come up with all these adjectives that kind of have that feeling of what sound does, but it's not really words that you can really quantify. It's like, yes, the fuzziness is, or the I don't know. And I feel like sometimes when we talk about material, because like I know the ability to resist cracking, like the durability, and that stiffness is one I had not heard of. So the ability to resist deformation. So just want to
something, and
throw
it's
that
critical
out
in
there.
this whole
I not
world
heard
of
that
soft
one.
robotics.
Mm-hmm.
Yeah. So this new technology, no surprise, could significantly benefit soft robotics and wearable technology. While traditional soft materials to act as muscles in soft robotics are great for smooth movements, so the stuff we have so far today before this development, they fall short regarding strength and precision. So their strength and precision, particularly existing materials used to date, are too rigid to lift heavy weights and too flexible to maintain precise control. So for the scientists in South Korea, this was their challenge. In this new development, researchers have tried to overcome these issues. For this, they use materials that could switch between hard and soft states. The researchers combined two key materials. First, ferromagnetic particles, and second, shape memory polymers. Now, the ferromagnetic particles respond to magnetic fields, allowing the muscle to be controlled remotely, and they also contribute to the muscle strength. Now, I'm going to stop for a second. When you come to computeramerica.com, get the show notes. What I do is I augment these little article highlights with optional materials. So I've inserted some additional material about ferromagnetic particles that's very geeky, and you can dive in here and dig into this to learn more about that if you're interested. But that's in the show notes. Come out and get that. We're going to continue on with the article here.
Yeah,
On
not,
the other hand,
and by the way, let me jump in and just say that not sponsored or anything like that, but interesting holiday idea for kids that are kind of the geekier kids who kind of like toys and stuff like that. They actually sell that as like a little kind of toy desk kind of thing where they sell the particles of magnets, and they come with two magnets. You can kind of play with the liquid. Just something for an idea for the geekier kids in your life.
That's fun. And you know what, Ben, that reminds me, usually every year, and maybe we'll do that if we do have a show next Friday, right after Thanksgiving, I'll do a collection of science, STEM, science, technology, engineering, math, toy recommendations for this holiday season. If you have a kid in your family who might be interested in that sort of stuff. Yeah, that'd be fun. So we have the ferromagnetic particles. That's ingredient number one. The other key ingredient is the so-called shape memory polymers. Very interesting stuff. They can change shape in response to specific stimuli like heat or light, and then return to their original shape. This allows the artificial muscle to be highly adaptable and change its stiffness. Now, again, I've inserted an optional side note of tutorial about what are shape memory polymers, because I had never heard of this before I read this article. So you can dive into that if you wish to in the show notes. And to wrap this little story up, by combining ferromagnetic particles with shape memory polymers, the researchers created a new type of artificial muscle that is both strong and flexible. So there's a very key advance in the world of soft robotics.
Yeah, it's going to have to be something that we kind of solve, because I think when people's first, the first thing they think of when they think of like robotic arm is, the arm just crushing something, just holding something and then just accidentally
right.
crushing it. That's a very real problem that they have to fix, and stuff like this is what they need to do. It way over my pay grade, but still very cool. That,
Me too.
that they're doing this. So very very cool article.
That brings up a good point, Ben. A lot of this stuff, clearly, it's way, way, way beyond my understanding. I'm just a lay person who's fascinated with science and technology, having been raised by a mechanical engineer and chemical engineer, and my grandfather was a physicist who worked on the transistor at Bell Labs. So I came from a family culture of this sort of stuff, but it's not my background, not my education, but I became a huge hobbyist and lover of all this technology. And so what we're doing, friends, is we're not trying to say that Ben and I fully understand this stuff. In many cases, we don't, but we just want to tease your brain, give you the links so you can dive deeper if you so desire.
You do a good job of not, and the articles themselves do a good job breaking it down, but also your side notes and kind of the key points that you take away, or break it down very easily. So ladies and gentlemen, as always, if you want to find out more, show notes. Story number 2, if you're following along, let's go ahead and talk about more research, and this one is going to talk about lithium, because I've been following a number of lithium stories. It's used in batteries all over the place, and Ralph, like, getting one of the, and I'm sure it's going to mention, kind of getting it is very hard. I didn't realize until like I started looking into some of these, like ever since there was a story a couple of years ago about lithium deposits found in like the Western United States, and they're huge deposits. Ralph, like, getting, and first of all, huge damage to the environment. Lithium is unfortunately not just sitting there, hoping that you pick it up, but also it takes like decades to get a mine going, and like literally 20 years to get a mine up and going and producing at full capacity. So it's getting this stuff is not easy. So hopefully story number two has an answer to this.
Yeah, right. This is about the world of lithium as a source for creating ultimately car batteries and batteries of all kinds. You're right. And just a little segue here for a moment. In the world of battery technology, as you know, Ben, from our past shows, sodium batteries, there's a world of effort out there to say, lithium, okay, I get it. But wait a minute, are there lesser expensive, readily available materials, i.e. sodium, that we can make a battery out of? And there's some really aggressive research going into sodium batteries. So stay tuned on that front, but I digress. This next story comes from Tech Explore. That's TECXPLORE.com. Check it out, folks. Wonderful website. Here's the headline. Novel electrochemical reactor can extract lithium from brine to address growing demand, and I added, for batteries. This comes from Rice University announcement. And there's a great picture of the scientists, the 3 team members who came up with this research. So a team of Rice University researchers have developed an innovative electromechanical reactor to extract lithium from natural brine solutions, offering a promising approach to address the growing demand for lithium used in rechargeable batteries. Now, a little reminder, think of brine as super concentrated version of salt water. So it's extraordinarily salty, okay? And this breakthrough, published in the Proceedings of the National Academy of Sciences, holds significant potential for renewable energy storage and electric vehicles. Now, as we all know, Ben, lithium is a critical component in batteries for renewable energy storage and electric vehicles, but traditional lithium extraction, to your point, Ben, methods have faced numerous challenges, including high energy requirements for the extraction of lithium and difficulty separating lithium from other elements, not least of which the whole mining and setting up the lithium mines and so on that you alluded to a few moments ago. Now, natural brines, this is interesting, in specific, salty water found in geothermal environments have become an attractive lithium source because traditional ore sources are increasingly difficult and expensive to mine, to your point a moment ago, Ben, right on target. However, these brines also contain ions other than lithium. So you think of the brine as a salty soup, and in this soup, there are ions of lithium, but along with that are ions of sodium, potassium, magnesium, and calcium, which have very similar chemical properties to lithium, making efficient separation extremely challenging. So there, Ben, that's the challenge these folks were facing.
Yeah. I mean, like, obviously we have talked a lot about other battery sources, and I do, and I'm sorry, I really do believe that, sodium ion or like all these other batteries, they are going to come into effect. But one of the most common comments we get on the show, Ralph, is like, where are the new batteries? We hear all the time about new battery technology, new battery technology. Lithium works and works so well. And while it hasn't been, a crazy meteoric jump, or I should say a giant exponential jump in battery technology, Ralph, like, we have figured out pretty well, the technology has developed, 5%, 10% year over year on how to get these lithium ion batteries better and more efficient year over year. They're just the best, kind of go-to standby. We know the technology. We know they're a risk. I mean, there's a reason you're not allowed to ship phones in planes anymore. It's because they kind of tend to. Oh wait, I have something for this. Because they kind of tend to explode. It's not exactly a good way to kind of go for the forever future, but for now, it's like our best option. So we know it's very, very good. So, but still, hey, alternatives and being able to get that lithium from other sources, always a welcome. And hey, anything better than having to get it from the ground. So
yeah, exactly. So again, what these researchers faced was this problem of the salty brine having lithium, but also having a bunch of other ions, again, sodium, potassium, magnesium, and calcium. And just a quick reminder, ions are atoms or molecules that have gained or lost one or more of their electrons, resulting in a net electrical charge. A little side note here, I inserted into the show notes. But going on now, the similarity in ionic size and charge between lithium and these other ions that we outlined means that traditional separation techniques often struggle to achieve high selectivity, leading to additional energy consumption and chemical waste. So that's part of the problem. Moreover, brines contain high concentrations of chloride ions that can lead to the production unintentionally of hazardous chlorine gas in traditional electrochemical processes, adding further complexity and safety concerns for the extraction process. So again, we're doing a long kind of setup here of what was the series of challenges. The Rice University engineering team has tackled these challenges with a novel 3-chamber electrochemical reactor that improves the selectivity and efficiency of lithium extraction from brines. Now, I know this is geeky, folks, but the takeaway here, the bottom line is there's a huge breakthrough here in extracting lithium from brines. And if we could do that, that could speed things up and lower cost and all that good stuff. But going on here, it says, unlike traditional methods, this new reactor introduces a middle chamber containing a porous, solid electrolyte that prevents these unwanted reactions by controlling ion flow as the brine passes through this chamber. There's an optional side note in the show notes about electrolytes here if you want to get a little refresh. And then it says this middle chamber exchange membrane acts as a barrier to chloride ions, preventing them from reaching the electrode area where they could combine to produce chlorine gas and thereby minimizing hazardous byproducts. The key component that enables highly selective lithium extraction that these folks at Rice University came up with lies in the specialized lithium ion conductive glass ceramic membrane on the other side of the electrolyzer, which selectively allows lithium to pass through while blocking other ions. And again, I confess, extraordinarily geeky, and we just gave you the highlights.
Yeah.
The quick cliff notes of this article. There's a lot more going on if you read their research paper and so on. If you want to dig deep, come out to the show notes at computeramerica.com and go crazy with the geek out.
It really shows that, sometimes we just talk about, metamaterials and, ones that are And don't get us wrong, because of our tech kind of lean, we usually get things like carbon nanofibers, carbon nanotubes,
Yes.
that kind of thing, Ralph. But like, this is a story built on other metamaterials that, they mentioned the lithium ion conductive glass ceramic membrane. It just rolls off the tongue, doesn't it?
Sure.
It's that allows them to kind of do this. It's, it is building on others' research, and that's really what it takes. So,
Yep.
yay for not producing chlorine gas. I hear mustard
Yes.
gas is pretty bad, so I guess even in a controlled setting, it would be a bad thing to kind of have. But still, very cool. And hey, Ralph, I believe there was I'm sure someone out there can go find the actual exact thing, but there's more lithium floating around in the ocean than there is in the earth, like in mines and like in the crust. Well, not the crust, I should say, but on
Right.
land, there's more lithium floating around in the ocean's waters. But hey, tapping it has always been very difficult. So
Yeah, there
hey,
you go.
maybe
Right.
this.
Big
So there you go.
breakthrough,
And of
actually.
course, I know that salt water isn't brine, but hey, one step at a time. So
Yeah.
there you go. Story number one. Story number two. Story number three. Let's go ahead and also research, but this is going to be very, very important. Ladies and gentlemen, if you've been out there and you've been able to hear, or if you've been able to smell some of these biodiesel, they smell like French fries, which much better than regular diesel. But biodiesel cars are something that were popular, a number of years ago, kind of fell out of favor because of electric cars, and of course now we have hydrogen cars. But it's still a technology that's being developed and still something that you should keep your eye on. So this is something that I have not heard of, and we're kind of recently new research going into this. Ralph,
Yeah.
let's talk about biodiesel.
Yeah, this is a great story. We're going into the transportation sector, pardon me, and we're talking about fuels. And in this case, we are talking, of course, about biodiesel. What you're going to find out in this article is this, of course, is a huge issue for the trucking industry and potentially trains, all of which use today diesel. So here, this story, it comes from the University of California, Santa Cruz, their news center online. Headline: New chemical process makes biodiesel production easier and less energy intensive. Subhead: Discovery by UC Santa Cruz researchers could accelerate biofuels adoption. Now, I'll do a little segue here. I live in Oregon, and when it comes around the winter time, our gasoline gets the injection, so to speak, of a corn ethanol, which is a biofuel. We blend that with regular gasoline to help reduce emissions when there's the inversion layer in the wintertime here in Oregon. And I suspect the same is true in many other parts of the country. But let's get into the story here. Oh, by the way, in the show notes, I have a link to a great article, a great tutorial article that says, what is the difference between biodiesel and diesel, traditional diesel? That article will fully explain the whole thing. It's wonderful. I highly recommend it. But with all that said, let's get into the story. UC Santa Cruz chemists have discovered a new way to produce biodiesel from waste vegetable oil that both simplifies the process and requires relatively mild heat. This discovery has the potential to make the alternative fuel source much more appealing to the massive industrial sectors that are the backbone of the nation's economy. I was alluding to trucking, trains, that sort of thing. A little side note here: vegetable oil, often referred to as yellow grease or recycled cooking oil, comes from several sources. For example, restaurants and food processing facilities. The food processing facilities, Ben, are going to be your greatest source of bulk used vegetable oil, by the way. And then I also inserted into the show notes, I asked the Microsoft Copilot AI chat vehicle, does the use of biofuels in combustion engines produce less CO2 than gasoline? The answer is yes. And get a load of this: corn ethanol, I mentioned that here as it's used in Oregon, can reduce greenhouse gas emissions by about 44 to 52% compared to gasoline. So you can see, wow, the appeal of biofuels in helping reducing the emissions of greenhouse gas is huge, right? So while some companies have turned towards electric vehicles to reduce their carbon footprint, the vast majority of fleets like trucks and trains and so forth still run on diesel, in part because biodiesel production so far is difficult energy intensive, and so has slowed adoption. No surprise. That's a setup for why this breakthrough is so important. Of all the energy sources used in the United States transportation sector in 2022, biofuels accounted for just 6%, a really small thing. And by the way, 2022 is the latest year I could find statistics on this.
I'm not really
Yeah,
surprised.
go
Like
ahead.
6% even seems high, because that means that, just over 1 in 20 of, I'm assuming, like 1 in 20 cars, or I should say trucks,
Yeah.
even at 6%, 1 in 20 is biodiesel. I guess, maybe I just don't, go smell them very often, or because the way they look wouldn't change. Like, it's not like they're built different. It's not like, the engine's still going to be the engine, and, it's all going to be cut and hidden. Ralph, maybe I just don't notice it, but 6% is still a pretty good number. Like, that's still 1 in 20.
Well, yeah.
I'm surprised.
And if this technology finds its way to be commercially viable, by the way, jumping ahead a little bit, this could kind of profoundly change the landscape in terms
100%.
of dramatically reducing. Because remember, again, you can mix biofuels like corn ethanol into regular gasoline to make a blend. So that could be part of the equation too, even if it's not 100% biofuel in a truck's tank. So in their study recently published in the American Chemical Society journal, Energy and Fuels, lead author Kevin Lofgren, and I have a picture of him in the show notes, details a new way to turn used vegetable oil into biodiesel that involves sodium tetramethoxyborate. I had to practice that a lot. That's a tongue twister. Tetramethoxyborate. This chemical, used to make the active ingredient that reacts with vegetable oil to make biodiesel, is considered unique because it allows the biofuel to be easily separated from the byproducts of production by simply pouring them off. Now, again, we're just giving you the highlights. There's a great deal of detail and more geeky science behind all of this if you get into their research papers.
Yeah.
Now, get this, Ben. Another benefit is this reaction using this tetramethoxyborate. So another benefit of this reaction can be completed in under an hour at temperatures as low as 40 degrees centigrade. That's 104 degrees Fahrenheit for us, saving energy and money. Wow.
Nice.
And according to the UC Santa Cruz researchers, the method they discovered turns about 85% of used vegetable oil into biodiesel and passes almost all industry standards for use as a fuel in heavy machinery and transportation vehicles. Oh, yeah, I forgot about heavy machinery like backhoes and cranes and all that kind of stuff. Now, there is a little qualifier here. The exception, in terms of being a really viable fuel, is water content in the fuel, though it is only slightly higher than acceptable value. The researchers expect that once this process is scaled up, the water content will be within acceptable levels. And you know what, Ben? This reminds me, one of the things we do every Friday is often we look at early research. We're not trying to tell you this is going to hit your trucks next week. No, it's something that's in development. It's a breakthrough, and it leads to a promising future development once it gets commercialized, once it becomes viably producible, I should say. And in this case, when they overcome the water content issue, which they're highly confident they will.
Right. It's, and then of course it's all a matter of adoption. And, it's, the article lays out a lot of good points about, how it's, once again, Ralph's title is Science and Technology Trends. This is definitely a science trend and where things are going. It's not going to be, vegetable oil that completely stops our oil production or the need for oil.
No.
It's not going to be, batteries that, lithium batteries, sodium ion batteries that are going to completely stop our need for oil. But Ralph, it's going to be, as you always say, a mix of things. It's going to be a little bit of everything, and it's going to lead to a better future. So, hey, just kind of hang in there. So, story number 3.
How about this visual? Think of the solution to climate change as a wheel with spokes. This is just one spoke in that wheel, and there's a bunch of other spokes that are going to contribute to ultimately solving CO2 emissions and greenhouse gas emissions. We're going to get there. I'm confident.
Absolutely. And it's really, it's going to happen. It's going to happen faster than you think because, like, obviously having dealt with what we've dealt with here in Asheville and, a lot of people, and of course, hopefully everyone out there on the West Coast is handling everything very well. But like, Ralph, whenever we read about this stuff, that's like, it's not commercially viable. Like, it would help a lot, but it's not commercially viable. Like, that scale is going to tip eventually where, it's going to make money sense, which is the biggest factor, but also it's going to make self-preservation sense. And, kind of when that tips, it's going to be a very fast process. But we're not quite there yet. So there you go. Okay,
there you go.
So story number 3, not to be a downer. Story number 3. Story number 4. Let's get back to the good stuff and let's talk about medical technology, because Ralph always saves story number 4 for some kind of advancement in medicine. And don't get me wrong, folks. Some weeks Ralph finds 4 stories that are all, and then of course even the honorable mentions are all medical stories. There's a lot of medical science out there that is doing amazing things and helping improve lives, either in trials or for people today. This one as well, just bone repairing serum sounds like just what I need in my life right now. And to see what scientists are doing, it's really incredible. Just taking the natural processes of our body, things that happen in nature, Ralph, and turning it up to 11. I mean, that's something science is so good at. So story number 4.
Yeah, this is absolutely, in terms of leaving you feeling good, the world of medical technology and science is so amazing. And if you want to be uplifted and given hope, wow, go to that world and you will not be disappointed. So this is a good example. This comes from interestingengineering.com. Headline: Scientists turn blood into bone repairing superpower to fight injuries and diseases. Wow, how could I resist that one, right? So let's set the stage here. Our bodies have an incredible ability to repair themselves, especially when damage is small, such as a small cut. Now, inspired by this natural healing process, researchers at the University of Nottingham, of course, in the United Kingdom, have unlocked the potential of blood to create transformative regenerative materials. The research team has harnessed the regenerative power of blood, to create a new biocooperative material. That's a key term, biocooperative material. Now, later in the article, you'll find out that this refers to mimicking the natural healing process that blood helps accelerate. Interestingly, this innovative blood-derived material has shown the potential to repair damaged bones in animal models in their experiments with animals so far. This could open doors to personalized regenerative treatments to address various injuries and illnesses, not just repair of bones. And then it talks about the lead scientist, a fellow named Alvaro Mata, M-A-T-A is the last name, who led the development at the University of Nottingham. Noted, quote, "For years, scientists have been looking at synthetic approaches to recreate the natural regenerative environment, which has proven difficult given its inherent complexity." So again, he's saying, for years, all of us in the scientific community have been looking at synthetic ways to pull this off. Here, we've taken an approach to try to work with biology instead of recreating it. Let that sink in. That's what he means by that business of biocooperative material. That's the theme here. So interesting.
Yeah, it's this idea that, the reason that we age, and I know there's like telomeres and a bunch of other stuff, and I'm sure there's it's 1,000 different things that kind of make us age. But Ralph, it's kind of, one of the main problems with aging is that your body stops having the ability to kind of heal itself. So, like we're even talking about kind of not reversing aging, but at least making aging more, more comfortable, being able to heal your body, in those later years, I'm sure is something that this research would very, very much help with.
Yeah. That's an interesting speculation about how its broader application could be impacting our future medical world here. So going on here, it says, as noted at the beginning, our bodies are incredibly efficient at repairing minor injuries like cuts and scrapes. This ability is largely due to the complex process of tissue regeneration. When we injure ourselves, the body immediately responds by forming a blood clot. This clot acts as a temporary patch, preventing further blood loss. Now, that's fine, well, and good for cuts and scrapes. The blood clot then transforms into a specialized tissue called the regenerative hematoma. So if you want to be really cool with your grandkids or something, or my grandchildren, and the next time they get a little cut and scrape, we put a little Band-Aid on there. Oh, we're dealing with a regenerative hematoma. What? So again, the blood clot then transforms into a specialized tissue called the regenerative hematoma. This regenerative hematoma is a dynamic environment filled with various cells, proteins, and growth factors essential for healing. So, and the next time I cut my finger or something, I'm going to really appreciate it more. How amazing this is. However, here's the problem though. However, larger injuries, no surprise, may overwhelm the body's natural healing abilities, the natural regenerative hematoma capabilities, requiring medical intervention. So, with all that said, in this new study, the University of Nottingham researchers learned from this process, from this natural process, and developed a way to enhance it. That's the biocooperative approach that they're talking about. For this development, the team utilized peptide molecules to engineer living materials that accelerate tissue regeneration by mimicking natural healing processes. And in the show notes, I have an optional side note here about peptide molecules. Very interesting. You can check that out if you want to. They combined synthetic peptides with a patient's own blood. Let that sink in. This is key. They combined the synthetic peptides with a patient's own blood, resulting in a self-assembling material. This is geeky, but that's part of this regenerative business. This approach enabled the engineering of regenerative materials that mimic and improve the natural regenerative hematoma structure and function. Biocooperative. Keep that buzz phrase in mind. I think this is a huge, fascinating trend in medical technology. The researchers demonstrated the ability to effectively repair bone in animal models using the animal's own blood. That's what they meant by personalized treatment. And again, this is not just limited to bone repair. It could be applied in many other areas. Ben, if this doesn't leave you feeling good, folks, and hopeful for the future, I rest my case.
Yeah, I really say that a trend that has not explicitly been stated, but I have picked up, kind of over these stories, Ralph. And I'm not saying that today, but I'm saying like over the course of as long as we've been doing this, I feel like the next big breakthrough that people are going to really notice in their lives, like there's various kinds of transplants and artificial organs and 3D printing, all that good stuff. But Ralph, like it seems like using a patient's own blood, in this case, blood, and other ones like, taking like, let's say skin cells and turning them into stem cells. And it's like, it's your own stem cells. Like, Ralph, I would say that using a patient's own tissues, DNA, using their own cells, that is going to be the big breakthrough for, a lot of these treatments and diseases that have a high chance of rejection or have a high chance of not, really getting worked into the body. Using a patient's own cells is going to be, the next big thing I think that people are going to see, and we're going to see a lot more or higher survival rates across the board because of it. So,
you're absolutely right, Ben. In fact, we've seen stories where you take a patient's cells and then through a very complex process, but you then bioprint cells that are from the patient. So you create more cells based on a patient's cells. Therefore, rejection is dramatically reduced. I mean, this is a very exciting trend, as it were, in the medical science and technology field. So you're right on target.
It's going to help a lot of people, and it's going to save a lot of lives. So you're right. That definitely should leave you feeling uplifted. So I will say that with that, ladies and gentlemen, if you've been following along in the show notes, well, there's more. And the honorable mentions is because we try to keep the show a little bit more condensed. Gone are the days, unfortunately, where, Craig used to do this for 3 hours at a time, 2 hours and, in an hour. So we try to keep it condensed and for your listening pleasure. And now with this, we're going to go ahead and go to the honorable mentions. These are stories that are great. They would have made it into the show had we more time, but we don't. So these are, listen, if you're a researcher who is hearing about this and like, oh, I only made the honorable mentions. No, you're doing good stuff. Keep doing it. But these are stories we just don't have time for. So Ralph, we can at least give the nice folks the headlines of the honorable mentions, and they can go to the show notes over at computeramerica.com to find the source articles and find the complete text. So yeah.
There we go. So we highlighted 4 articles in relative detail. In the honorable mentions, we highlight 4 stories that please come and get the show notes at computeramerica.com and check these out. We talked about biodiesel. Well, guess what? Our first honorable mention, which comes from Washington University, their newsroom, headline here, researchers create novel electro-biodiesel more efficient, cleaner than alternatives. So here's another track, another tributary of research in the area of biodiesel. So that's a hot area right now. So check that story out. We've got the link and image and so forth and a couple of words to give you a taste, a tease. The next one comes from the MIT, Massachusetts Institute of Technology newsroom. Headline, MIT engineers make converting CO2 into useful products more practical. Subhead,
and it looks like they started with the ice cream sandwich.
The efficiency of electrochemical reactions that turn carbon dioxide into ethylene and other products. Wow.
Yeah, and I was saying it looks like they started with the ice cream sandwich. It's good choice.
Like that, doesn't it? It's funny looking thing.
Good choice.
Anyway, it's just so interesting to see this world of dealing with CO2. You can capture CO2, you can bury it under the ground, you can do this. But I like the field of research, and there's a lot going on all across the world, extracting CO2 from the atmosphere, from the air, and converting it into products. That's a win-win. Instead of just burying it in the ground. Okay, well, with that said, let's move on to the next honorable mention, number 3. Soft robotic shorts. We're talking about wearable shorts, right? Could assist older adults and people with limited mobility while walking. Really great example of kind of the hybrid robotics, human body working together. Talk about biocooperative. Let's use that term from a previous article. This is a great story from techexplorer.com. Again, soft robotic shorts could assist older adults and people with limited mobility while walking. It's actually more than just the pants or the shorts. There's an apparatus that goes on your torso as well. But check this story out. It's very, very interesting in the world of prosthetics.
Real quick,
and then the
what I like
last
about
honorable mention for this week comes from sciencealert.com. Great website. Headline, signs of lung cancer can now be detected when you exhale. What? Wow. That is just some signs of lung cancer can now be detected when you exhale. Run, don't walk to this story. Absolutely amazing.
That would be a much less, less invasive, but of course, hey, just I'm sure an early warning sign, something that's very simple to do. So that one a lot. Like, really all the honorable mentions, again, could have been stories in their own right.
Yes.
But we just didn't have time. So, ladies and gentlemen, I want to thank you so much for, of course, coming out and, listening to the show. We always appreciate that. And Ralph, I want to thank you, as always, for getting these together, doing a great job on the show notes. And ladies and gentlemen, if you want to see all of Ralph's great work, hey, check out the site, computeramerica.com. And of course, you can find the show notes there with everything that we talked about here today. So until next time, and again, keep an eye on the website. We'll let you know, if we have a show up on next Friday. We will see if Ralph's boss is going to let him. But if not, ladies and gentlemen, a lot more coming from Computer America. Thank you so much. We'll catch you next time. Have a good one. Stay safe, everyone. Bye.